All right, welcome back. We are going to continue our discussion on 10.4, which is solving radical equations. Our steps for solving radical equations remain the same as they were the last time we looked. This time, we're going to be looking at more complicated equations that need solving. The first step is to isolate the radical. So if you see here, the 2 minus y is under the radical on the left side, and all the other pieces that are not under the radical are on the right side of the equation. So the radical is isolated, it's by itself. So once you have that first step completed, your second step is to square both sides. So I'm going to go ahead and start by squaring both sides of my equation, keeping in mind that the square and the square root cancel each other. So, sorry, I have to rotate my screen here. So then that will cancel out the radical on this side over here. So we're left with 2 minus y equals y squared. Now, when you have a y squared and a y term, that indicates that we have a quadratic equation here. So then we're going to have to be using our factoring skills to solve this. So in order to factor, we need to get all the terms on one side of the equal sign, so we have a 0. So we'll subtract 2 and add y to both sides so that this side becomes 0. And we have y squared plus y minus 2. So to factor, remember, we're looking for things that multiply together to equal -2. And we want them to add to be the term in the middle here, the 1. So things that multiply to 2 are 1 and 2. And that's it. That's my only pair. But if I want the 1, when I add those up, I want it to be +1. So then that should mean that the 2 should be positive and the 1 should be negative. So I'm going to make my 2 sets of parentheses here. And each one's going to get a y. And then I'm going to put -1 and +2. And that equals 0. So then we have setting each of our parentheses equal to 0. So y minus 1 is 0. So y is 1. Or y plus 2 could equal 0. And y could equal -2. So that brings us all the way through step 3. We have isolated the radical. We've squared both sides. And then we used our quadratic solving skills of factoring to solve the equation. So now we have 2 solutions. It's a little different than the couple equations we looked at last week. So now we need to check them to see if they're going to work. So remember, to check, you want to take your y value and plug it in where you see a y in the equation. So I'm going to take out the y and I'm going to replace it with a 1. So I have 2 minus 1 equals 1. So let's see. Does the square root of 2 minus 1 equal 1? Well, the square root of 2 minus 1 is just 1. And the square root of 1 is 1. So this checks out. 1 is, in fact, a solution to this equation. Let's see if we get the same results when we plug in -2. So I've got 2 minus, and I'm going to plug in a -2 there. I'm already starting to think that this is kind of suspicious because I've got a negative over here outside of a radical. But let's see what happens. So I've got the square root of negative and a negative. So a negative minus a negative, that's a positive. So that's the square root of 4. And does the square root of 4 equal -2? Well, no. The square root of 4 is +2. So this is not a solution. So when you get a solution algebraically and it doesn't check out, that is called an extraneous solution. Extraneous solution. And so what it just means is that number didn't work out when we checked it. So our only true solution here is right over here. So that y equals 1. That is our only solution to this equation. So again, check the steps. Right here, we isolated the radical at the very beginning, and then we squared both sides, and we were able to solve it using our factoring method, and then we had to plug our solutions back in to check them at the end. So this required a lot of previous skills, things that we had learned before in previous units that we had to incorporate with the factoring and then the checking our work. So if you need a minute to pause the video right here, you can take some time, make sure you have it copied down, and that you can follow your work and understand where we went wrong, or where we went with all of our work, and if something went wrong on your paper, make sure you get it corrected. Okay, now that you guys are ready to move on, we're going to come down to the next example here. We've got another equation. This time is y equals the square root of 2y plus 3. So we're going to follow the same steps we did before. First off, we got to see if that radical is isolated, and in fact it is. It's by itself already. So we're ready to square both sides. And the square is going to cancel with that radical, so we're going to be left with y squared equals 2y plus 3. Now remember, in order to factor, you have to get your equation equal to 0. So that means that you're going to want to subtract your 2y and your 3 to the other side of the equation. So let's see here. I've got y squared minus 2y minus 3 equals 0. So we're looking for things that multiply together to equal negative 3. So 1 and 3 multiply to 3. That's it. So then we need to say, okay, how am I going to get 1 and 3 to add together to equal a negative 2 in the center? I think that'll happen if I make the 3 negative and the 1 positive. Yep, that'll be negative 2. Just checking that math in my head. Negative 3 plus 1 is negative 2. So then I'm going to break this into 2 sets of parentheses. Each set of parentheses gets a y. And then I'm going to use my pair of factors. So a plus 1 and a minus 3. And then I'm going to set each of those factors equal to 0. So we're going to go y plus 1 equals 0. So y equals negative 1. And our second factor is y minus 3. Y minus 3 equals 0 means that y equals 3 when I add that to both sides. All right, step 4, time to check, see if these things actually work out. So we've got y equals the square root of 2 times y minus 3, or plus 3, sorry. So I'm going to plug in a negative 1 in both places that I saw my y. So then we need to check. So this would be negative 2. Negative 2 plus 3 is positive 1. And we need to check, is the square root of positive 1, which is just positive 1, equal to negative 1? No, those are not the same. One's positive, one's negative. So that means that this is not a solution. It is extraneous. Extraneous. All right, let's check this 3. Maybe the 3 will work out. 2 times 3 plus 3. And anywhere I see a y, I'm going to take it out and put in a 3. So does 3 equal the square root? 2 times 3 is 6. 6 plus 3 is 9. And the square root of 9 is 3. Hey, look at that! They checked out. So that means that y equals 3 is our solution. Awesome. All right, so just to recap, we started with squaring both sides because our radical was already isolated. Then we got it to equal 0 here so that we could factor in our next line of work. Then we had two solutions, so we had to plug those solutions in to see if they would work. We found out the negative one was an extraneous solution, but that the positive 3 was okay. So keep in mind that just because you have two solutions doesn't mean that they are both going to work, or it doesn't mean that one has to be extraneous and one has to be a true solution. That's not the case. So you can have two extraneous solutions. You can have one extraneous and one non-extraneous. You can have a positive true solution, a negative true solution. Don't get caught up in thinking that you always have to have one that's not going to work. Okay? Just kind of want to forewarn you of that. All right, last example. We're going to kick it up a little bit. So here we have an isolated radical, but there is an expression on the other side that's a binomial, right? This x minus 3 is a binomial. So when we square both sides, we're going to have to be careful here because the radical is going to cancel over here. So we're going to have x plus 2. But on the other side of the equal sign, we've got x minus 3 times x minus 3. We have to FOIL again. So let's see, that's going to be x squared minus 3x minus 3x. And then a negative times a negative is plus. So plus 9. So to multiply all that out. All right, we got to combine some like terms here now. Get this whole equation to equal 0 so we can factor. Lots happening. So for a moment, I'm going to leave this x plus 2 right here. I'm going to condense what's on the right. So minus 3x is a minus 6x. Bring down the plus 9. Now let's subtract the x and the 2. I'll line them up there with their respective terms. So we've got 0 equals x squared, 6x, negative 6x. There we go. Negative 6x minus x is negative 7x. 9 minus 2 is 7. Oh, but it should be positive 7. Cool. What did I do wrong? That was a 3. Did you guys see that? This was supposed to be a 3. And then it turned into a 2. So that's a 3, and that's a 3, and this is a 3, and then that 7 is 9 minus 3, which is 6. Whoops, my bad. But now it's factorable, so that's exciting. All right, so let's see here. The things that multiply to 6, 1 and 6, and 2 and 3. And if I make them both negative, right, that would get me to negative 7. So I'll have x minus 1 and x minus 6 as my two factors. So x minus 1 equals 0. So x equals positive 1. And x minus 6 equals 0. So x is positive 6. Okay, I'm good with this. So let's see if we can get a solution to check out here. So I've got the expression where we have the square root. I'm going to double check, make sure I copied it right, of x plus 3 equals x plus 2. Is that right? Or is it x plus, no, x minus 3, sorry. So everywhere I see an x, I'm going to take it out and I'm going to put in a 1. So the square root of 1 plus 3 is 4. And the square root of 4 is 2. Over on the